So let's go to have a look to the electromagnetic radiation and the risks. What are electromagnetic fields in our working activity? So many of our equipment, since they have electric power lines, can produce electromagnetic field. This is just a brief history, but you can find also the reference for the directive from the European states for the electromagnetic fields. All, well, let's say there are many types of electromagnetic field and related exposure. In particular, we can have high energy radiation from X-rays, gamma rays, and some higher energy ultraviolet rays. So these are, let's say, some radiations that can affect the human body, and in particular the cell, on the atomic level due to the energy that they have. And these can contribute to genetic mutation and cancer in the, let's say, broad condition. When you have a specific magnetic field, you can find the label that are in the top of the slide. In this area, when you can have a magnetic field, especially for several conditions, and the intensity of the energy due to the rays that are present for specific equipment, for example, you can also see that people with the pacemaker wearers are not allowed inside, for example, as you can see here in the top. On the other hand, we have also low frequency radiation. And in this case, you can see the label of non-ionizing radiation hazard, as in the yellow picture. And also in this case, for example, we have specific electromagnetic field from radio frequency radiation, visible lights, and also infrared. But these are very, very low. And in general, they cannot have a very important effect on cells and so on for the human body, let's say. But also in this case, a general warning information has to be provided for the workers that are working with this equipment or in this area. So, as we said, the high frequency and low or mid frequency electromagnetic field can be present, and in general, I can provide you the assessment of from the European Union, giving the information about the reference from the regulations, also in Europe, for example, or other European country, as you see in the left of the slides, in the table in the left of the slide, where many countries adopted the European recommendation. Other countries adopt more restrictive limits and recommendation. And for example, for Italy, which is, let's say, close to me, we the limit for the electric fields is 5 kilowatt per meter, since also the distance from the source is important. The magnetic field is 100 microtesla. And also we need to assess several step warning, for example, for attention values or quality target, depending from the exposure, the duration of the exposure, and so on. So this is just a general information. So you have to check for your specific country. Now, let's go to the food contact regulation, which is, as we said before, very, very important for our project, but also for other projects dealing with the packaging for food application. In general, the food contact material are defined as all the materials that, and articles also, intended to come into contact with food. So this is not only for packaging and containers, but also for equipment, cutlery, dishes, and so on. So not only for the general packaging. And it's important also to consider also the processing equipment. So every time I need to use an equipment to produce the packaging for food, I need to assess the food contact compliance. And this is something that is not so clear, but also in the research, for example, in BIOnTop, it could be important to analyze all the equipment that provide, for example, pellets, or if we needed to provide a tray, the material for the production, and so on. It's important to evaluate the safety of this material for, or better, because of all the chemicals that are in the formulation that is used for the production of these materials. These chemicals can migrate from the material into the food due to the, let's say, storage condition of the food, due to the duration of this contact, and due to the, let's say, characteristics of the food that we put inside the material, or better, in contact with the material. In general, we have an European regulation specifically for food contact materials, and we have also a regulation for the good manufacturing practices. Both these regulations must guarantee that any potential transfer from the material in contact to the food does not raise safety concern, does not change the composition of the food in an acceptable way, for example, for, let's say, taste, odor, color, and so on, and does not have adverse effect on the characteristics of the food, the main characteristics, let's say. And this is the scheme of the general regulations that has to be applied. The framework regulation for the food contact compliance is 1935 from 2004. This is specifically applied for food contact materials. And then we have the Good Manufacturing Practices Regulation 2023 from 2006. So we have also for the food contact materials specific regulations applied on different materials, and we are going to see them. And we have also specific substance regulation for specific components, chemicals that can be in the formulation. This is at the European level. Then for different European member states, we can have specific regulation depending from the material of the packaging or the equipment or what we use as material in contact with the food. For example, for paper, metal, glass, and so on. But these are specifically applied from different European member states. So this is what more or less, I already said in the previous slide as comment for all the European framework that apply for food contact materials. The body that needs to verify the safety of the food contact materials is the EFSA, which is the European Food Safety Authority, that publishes scientific opinions and advices for risk managers, for producers, and so on, in terms of the evaluation and certification and verification of the compliance of the safety of all the substances that are used to produce materials which come in contact with food, and also for the related processes for the production of these materials. From the EFSA website, I can show you the last timeline from the certification steps. So this is, let's say, a timeline providing information on the improvement of the regulation, on scientific publication, protocols developed by the authority to update all the information. For example, as you can see, from 2021 in November, updated of bisphenol A in foodstuff was published, and so on. You can be updated by checking on the website. So about the regulation on food contact material, 1935, the scope and the object of this regulation is to ensure functioning effectiveness of the internal market as regard placing on the community market of material and object that has to come in contact directly or indirectly with foodstuff. So this is regulation has to be applied for material that are going to come in contact with the food. So for example, for a new packaging that is produced from the research, we need to apply this regulation. For also material that are already in contact with the foodstuff, or for material that in the future are expected to come in contact with food. So we need to, in all this situation, apply the food contact regulation. There are many articles, but in general, we, as the definition of the product conformity, the labeling of the product that is evaluated according to this regulation, the declaration of the conformity, and also the traceability of all these steps of this evaluation. Here, the label for a material that is food contact compliance. We can find it in many of the materials that we can buy, for example, as a knife, fork, and so on, plates, and so on. And this is the statement that is important. So the food contact materials must not transfer their components into the food in unacceptable quantities. And this is evaluated with the migration test, and we are going to see them. So in any case, we need to evaluate this migration to guarantee that no chemical substances that can be present in the material can be transferred to the food. In the Annex 1, we have the definition of the types of material that are regulated by specific legislation. And in particular, for example, for the plastic material, we have the Regulation 10 from 2011, and we are going to see it thanks to BIOnTop specific application for plastic material, but also for example, for ceramics or regenerated cellulose or active and intelligent material. We have already available specific regulations at the European level. For many other materials, there are guidelines of the Council of Europe or specific European states regulations. So let's see about plastic regulation 10 from 2011. This regulation is divided in 6 chapters and 6 annexes. And we can find, just in summary, the field of application. So all these materials that are listed here are considered within the regulation for plastic material. So material and articles and parts consisting exclusively of plastics, plastic multi-layer material, material and articles referred both point before, printed or coated, and also, for example, multi-layer, multi-material, taken together with also adhesives or several other components, let's say. On the contrary, for resins, rubber, and silicones, these are not considered within regulation number 10. So we have not to check this material with according to this regulation. The list of considered and authorized substances from this regulation is provided in article number 5 and also in Annex 1. And we can see the table with all the information of this list. Which are the specific requirements on these substances? We need to verify and comply with the specification in terms of specific migration limits, and we are going to see what it is, overall migration limit as well. We need to verify the restriction and specification in a specific column of the table 1, and we are going to see it, and the detailed specification also in point 4. Sorry. About nanomaterial, these can be used only if they are already authorized and mentioned in the specification of the Annex 1. And you can check on the Annex 1 which are the nanomaterial that can be used. So what is the overall migration limit? The overall migration limit is the maximum permitted amount of non-volatile substances that can be released from a material, a packaging that is in contact with food simulants. So this is this consider all the chemical substances that can be, let's say, eluted, can migrate from the packaging to the food. And for evaluate this, we use the food simulants or one or more food simulants. The food simulant is a solvents it can be with water, but also an organic solvents that imitate the food contact, depending from the specific food contact application for the final usage of this material. The specific migration limits provides the limits for any specific chemical components that can migrate from the material to the food or to the food simulants. It's important to consider that we can have an overall migration limit, and we do have this overall migration limit for all the chemical components inside the material. On the contrary, the specific migration limits can be applied only for specific chemical substances, and it's different from one substance to the other. In general, the specific migration limits is expressed in milligram per kilogram of food product, and in case that not specific migration limits is provided for a chemical substance, we use 60 milligram per kilogram of food as limit for the chemical substance. For the global migration limit, overall migration limits, it's more or less the same. We use 10 milligram per square decimeter of contact. So let's see about table number 1, that is the union list with all the chemical substances and the information that are inside this table. And also later we can see the compliance testing for this evaluation. So this is more or less what is provided. Table 1 in the Annex 1 provided information for the substance with the number unique identification of the substance. More than 800 substances are provided in this list, in this table. Then a reference number for packaging material, the CAS number, the chemical name, indication that the use as an additive or auxiliary substance of the polymerization is authorized or not. The indication that use as monomer is authorized or not. The identification that the results of the migration can be corrected for specific coefficient depending from the reduction of fat consumption. This is specifically applied for material that can be in contact with fat material, fat food. Then we have the specific migration limit information, or if there is a specific group restriction number, depending from the number of different chemical molecules that are in this specific group. As I said, for example, for aldehydes, we have formaldehyde, glutaraldehyde, and so on, and we can have a total limit for all the group of these substances. And then we have a specific restriction and specification and specific notes for the verification of the compliance. So this is the table mainly that you can see starting from the beginning till 885 substances. And these are all the information in all the column that I just described to you. Mainly, this is for the fat reduction factor, and you can find yes or no as information. This can indicate, for example, to be used only as, for example, to be used if it depends from the cases. And the last column, how to verify the compliance of the specific substance. Some substances are not present in the list, and they, on the contrary, can be used in the production of a material or an article. For example, here a small list, but we can find many more. Dyes and solvents, substances not present in the list, but can be used with national, according with the national regulation. Many metal salts, for example, if they are present as authorized acids, phenols, alcohols, and so on. Mixture obtained from authorized substances without a chemical reaction of components. Not intentionally added substances, but can be produced, can be formed within the packaging during the production, for example, and also polymerization auxiliary substances. We have a specific restriction for metal components, and here the list of barium, cobalt, copper, iron, lithium, manganese, and zinc. And also for primary aromatic amines, you can find that the detection limit 0.01 milligram of substances per kilogram of food has to be verified. So also the analytic methods to apply for the quantification of the specific chemical substances has to be comply with this value as a lower detectable value for the analytical test. In the Annex 3, we can find the food simulants that we need to use for the simulation of different food that we can put in contact with the material. In the previous regulation, for example, there was also water. And for this, just a consideration, here in ARCHA, we continue to use also water, since in some case we can understand if there are, let's say, some different behavior coming from the material that is in contact with the other simulants compared with the water one. This is like a blank sample. And then we have, for example, ethanol 10%, acetic acid 3%, ethanol 20%, ethanol 50%, vegetable oil, and we can see when we use these different simulants in different conditions, and also the simulant E, which is a simulant used for solid contact, material that come in contact with solid food, sorry. In general, we use simulants A, B, and C when we need to evaluate the contact with the hydrophilic food. Only simulant B when we use acid food, simulant C when we use alcoholic food, and then for simulants D1 and D2 for lipophilic food, and depending from the type of the food, and I can show you very soon which are the identified simulants depending from the food that you want to consider. And then simulant E for dry food, so for solid food. Here, there is the identification of the specific food simulants depending from the material the food that we are going to pack or to put in contact with our material. For example, for beverages, you can see that there is identified simulant B and C, or B and D1, and so on. And here in this table, you can find all the general description of the food and all the identification of the different food simulants that you have to verify for this contact. So what have we to do when we need to verify the compliance of a material in contact? The first statement, we need to demonstrate the compliance with the overall migration limits, so 10 milligrams per square decimeter for all types of food by using distilled water or water of equivalent quality, or food simulant A and food simulant B and D2 for all the packaging, all the material that we are going to put in contact with food. All the other conditions, all the other requests can be applied depending from different conditions of different food, quality of food, let's say. But in general, if we use A, B, and D2, we can cover all the type of food. Sorry. Then about the condition of the migration, we need to apply different contact time and different contact temperature depending from the, let's say, real condition at the end for the contact. So we need to use the worst condition that can be applied, and especially for the material that are not yet in contact with food, we usually use a specific condition that consider more than 30 days at room temperature by testing the material for 10 days at 60 degrees. With this condition, with this experimental condition of the total migration test, we can provide the verification of the migration for the material that has to be in contact with the food for very, very long time. On the contrary, for example, if we think about tea bags that is produced within, for example, BIOnTop project, we need to evaluate a duration of the contact for 5 minutes, that is considered for all the contact time lower than 5 minutes, but with the temperature of the contact 100 degrees, which is more or less the temperature of, let's say, very, very hot tea during the boiling of the tea. On the other side, just this slide for informing you that for material that are considered to be used into repeated contact with food, for example, plates, trays, and so on, that can be used more than one time, we need to perform the test 3 times on the same sample. So using the same specimen and changing every time the simulants, we need to assess the overall migration from the first, the second, and the third test. And usually, if these results will not increase, we can find we can compare with the limit the results obtained from the third test. And this is considered and evaluated for the repeated use articles. In the annex, we have also the standardized testing conditions that are listed here in this table. They can summarize several general conditions for the execution of the test, depending from the duration of the contact and the temperature of the contact. But you can apply specific condition depending from your specific application. So this is just a general list. For the, let's say, practical execution of the test to verify the overall and the specific migration test, we have the experimental condition in the N1186 series of methods. Here we can have, for example, the description of the test performed for plastic material to perform the quantification of the overall migration into olive oil by, for example, total immersion, part 2 of the series, and so on. Here you can have the list. I think you can find them online, or perhaps you need to buy them, but they describe step by step all the procedures, all the steps that you have to perform to finalize the quantification of the overall migration. In addition, for the specific migration test, you can perform the same test as for the overall migration test, but then you have to quantify what you, let's say, have as overall migration by specific method, depending from the chemical substance, for example, by gas chromatography, liquid chromatography, and so on. And here I put some videos, some reference of all the information regarding the food contact materials, the food contact regulation, and so on. So, questions, and thank you.